Algebra students, in this video we are going to look at the idea of rational exponents now. So going back to what we just finished up with, looking at square roots, cube roots, and nth roots, where n is the index of the radical and tells us which root we're going to take. I'm going to show you a way to write these in a little bit different format. First of all, if I want the square root of 4, and obviously the square root of 4 is equal to 2, another way that I could write that is I could take 4 and raise it to the 1/2 power. So rational exponents is in our title. Remember, rational for us means can be written as a ratio or fraction. So 1/2 is a rational number, thus a rational exponent. 4 to the 1/2 power is also equal to 2. If you don't believe me, type it in your calculator. Go ahead and find out. Or in this example, I could take 8, because the cube root of 8 is 2. That means 8 raised to the 1/3 power is also equal to 2. Pretty fancy stuff. Again, you don't believe me? Try it out for yourself. So finally, if I have the nth root of a is equal to b, if I were to take a and raise it to the 1/n power, it would equal b. So it's just an alternate way of writing that root expression. So the idea is when I have fraction exponents, those mean I am taking roots. And n, which is the index of the radical, tells us which root that we're going to take, n is going to end up, the index is going to end up in the denominator of that rational exponent. So a couple more examples on this next page. Now first of all, why does it work? Well, here's the idea. If I were to take the square root of a and square it, I would get a. Something that I think makes sense to us. We've done plenty of that. Now, if I were to take a to the 1/2 power and square it, based on the properties of exponents, if I have a power raised to another power, I multiply the exponents together. Well, 1/2 times 2 is equal to 1, so that'd be the same thing as having a to the first power when I was all done, which is the same thing as having a just by itself. That's a to the first power here as well. So if those two expressions are the same, when I square this and when I square this, I both end up with the same thing. I think I could probably confidently say that these two things that got squared must equal each other. So the square root of a is equal to a to the 1/2 power. Index of this radical being 2, so 2 ends up in the denominator of the exponent. In general, if I have the nth root of a raised to the nth power, it ends up becoming a to the first power. Or if I have a to the 1/n power raised to the nth power, I multiply those exponents together and I get 1, so I get a to the first here as well. So that must mean, again, that the insides, the nth root of a and a to the 1/n power, must be equal to each other. So using radical notation, you'll get practice with this in your worksheet, but if I want to turn 8 to the 1/4, currently this is rational exponent notation. Use radical notation means to write it as a root. Well, 4 is in the denominator of the exponent, so this is going to be the 4th root of 8. That's how I'd rewrite that expression. This next one, I got 5 to the 2/3. All of a sudden my numerator isn't 1. Well, the key is that I've got the root is right here. The denominator tells me which root I'm going to take. So I'll start with that. I'll take the cube root of 5. Now because I've got a 2 up here, this would be like having 5 to the 1/3 power, in parentheses, squared. If I had that power raised to another power, I'd multiply those exponents together. 1/3 times 2 is 2/3. So that must mean I take the cube root of 5 and square it. I've got 2 of those cube roots of 5 being multiplied together. So what happens is the numerator tells me the power to which I'm going to raise that expression. The denominator is telling me which root I'm taking first. So power over root. So when I have 20 to the 5/2 power, well, 2 is the root, so I have the square root of 20. And then that's raised to the 5th power from there. So square root of 20 to the 5th. Now, using rational exponent notation, sometimes we'll practice going the other way. So I have the cube root of 16, and I want to rewrite that with a rational exponent. That would be 16 raised to the 1/3 power. You got to be careful when you write these two that you don't have 1/3 next to the 16, because then it might look like 16 and 1/3. Really, it's 16 raised to the 1/3 power. Here I've got the cube root of 27 to the 5th. Okay, that's going to be 27 to the, let's see, power 5 goes on top, root is 3, that goes on bottom. So 27 to the 5/3. And one more, 15 is raised to the, let's see, the third is the power and 8 is the root, so that must be 15 to the 3/8 power. Now when it comes to evaluating, if you're told to evaluate, that means I want to know what is the value of this expression. So 27 to the 2/3 power. What that means is take the cube root of 27, which is 3, and square it. Well, 3 squared is going to be 9. If you're ever unsure, you can always type this in your calculator and you'll come up with the right answer. Next one, the cube root of 8 to the negative second. Well, the cube root of 8 is 2. And now 2 raised to the negative second, well, that's a negative exponent, which should go in the denominator. So now I have 1 over 2 to the positive second, which really equals 1/4. Again, if you don't trust me, type it in. Change it to a fraction because it'll be a decimal. And finally, the cube root of negative 64 is equal to 4. Now this is interesting because normally with square roots, we couldn't take the square root of a negative number without adding I, the imaginary unit. But a cube root, I can take the cube root of a negative number because that would be negative times negative times negative. 3 negatives multiplied together is negative, so this is going to be okay. So that's going to be negative 4, which is the cube root of negative 64, raised to the 4th. Well, negative 4 to the 4th is going to end up being positive 256. Looks like a good value to me. Now another thing you might be asked to do at some point is to approximate roots. Approximate means it's probably going to be some decimal expression that's not very nice to look at. So the last thing would be to then punch these expressions into your calculator. I'll show you how to do that. If I want the 7th root of 1,695, I would take, there's a couple ways you could do this. Now, first of all, you could go to the math menu of your calculator and find this X root option. So if I were to choose that, what happens is I have a root symbol that's got a box where I can put in any index that I might choose to use. So in this case, I'll take the 7th root of 1,695. If I hit the right arrow, that jumps me out of the radical side, I should be good to go. So I hit enter, and there's my number. The other way I could do this is I could take, let's see, if I hit alpha F4 maybe? Alpha F2 for your newer calculators. That's where you could also get that X root option. So I choose the 6th thing. It's the same way of typing it, it's just a different way of getting there. So 1695, and enter, same value. The other option would be if I don't want to find that root, I could take this and raise it to the 1/7 power. Same thing. So rational exponents can sometimes make a calculator work just a little bit easier. So I'll show you the other ones. If I get 85 to the 1/6 is the next one I have to do. 85 raised to the 1 divided by 6 power. As long as that stays in parentheses, you're good to go. If you don't have math script enabled, you might have to do 85 raised to the parentheses 1 over 6 power. For those of you with the older calculator, you definitely need the parentheses there. But it'll give you the same thing. So just showing you how to do that on your calculator. And that would be how to evaluate nth roots at different places. Even negatives, same thing. We should be good to go.